Let us focus on alcohols. Okay, so just similar to everything we've been doing so far, all these organic compounds have functional groups, they have general formulae, and so on, right? So with alcohols, their functional group is the hydroxyl group, this OH, or the oxygen and the hydrogen atoms, right? So this group of atoms are what's called a hydroxyl group, and they happen to be the functional group for alcohols. So for example, if we have, let's take one alcohol as an example. Of course, we'll learn how to name them later on in the video. And then if we have, let's say, ethanol, you would have your hydroxyl group there, or at the back or at the top, it doesn't matter really. And then you have your, right, this is ethanol. Okay, and then this is the hydroxyl group, and it's our functional group. Okay, so that's what we mean. So that right there would be what you call not ethanol, sorry, methanol. This is methanol, because remember, if it has one carbon atom, it's meth. If it has two, it's eth, 3 prop, and so on and so forth. So this one would be methanol. So that's what a functional group of the alcohols would look like in a structural formula. So now the general formula for alcohols is CnH2n plus 1, and then you find your OH group there, your hydroxyl group, which is the functional group of the alcohols. Now, similar to haloalkanes, right? Alcohols have 3 types as well. You have a primary alcohol, secondary alcohols, and then tertiary alcohols. So of course, depending on where the hydroxyl group is attached, is it attached to a primary carbon atom, or is it attached to a secondary carbon atom, or a tertiary carbon atom, then it will determine the type of the alcohol itself. So the rules are the same when it comes to deciding whether this is a primary, secondary, or tertiary alcohol. Those rules are the same as the ones we had when we were looking at primary, secondary, and tertiary haloalkanes. So just to illustrate that, we will look into that after understanding the rules of naming alcohols. Okay, so it's still the same procedure. We always have to determine the longest continuous chain, right? And then in this case, it must contain our hydroxyl group, which is the OH, right? And then once we have done that, we must then count the number of carbon atoms present in that parent chain or in that long continuous chain. Of course, from there, we then use our table with stems. We know that if it has 1, it will be meth, and then if it has 2, eth, if it has 3, and so on and so forth, up until dec, right? So if it had 2, the parent chain name will be ethanol, as an example. All right, so if it has 3, it will be propanol. If it has 4, butanol, and so on and so forth. Okay, so then what happens is similar to what we were doing for the alkynes, alkenes, and haloalkanes. We always start numbering from the side that will be nearest to our hydroxyl group in this case. So in the case of haloalkanes, we would name, or we will start numbering from the end that is nearest to the halogen atom, right? So in this case, it will be nearest to the hydroxyl group. And then now we number the substituents as well, and then we arrange them alphabetically. By substituents, we're talking whether is there an alkyl group present, is there a halogen atom present, And then this also includes the hydroxyl group itself. It's also a substituent, right? Because it replaces, it's in a place where normally hydrogen would sit, right? So if you remember, before this could become methanol, when we're dealing with alkanes, this was gonna be like this, which is methane, right? So if you check, but now it's methanol, which means we replaced this hydrogen atom with a hydroxyl group, OH, right? So this hydroxyl group is a substituent. It's substituted where there was it substituted hydrogen, right, and took its place. Okay, so that's why we call them substituents. So all of them, the alkyls, the halogen atoms, a hydroxyl group in this case as well, they are called substituents. Okay, so if there are two hydroxyl groups, because it happens, it is called a diol, and the name will end with diol. So this will be now our suffix. So this would be the suffix, right? If you remember, this is similar to when we had two double bonds in a parent chain. We would call that a diene. For alkenes, we would call it a diene. So now we're dealing with alcohols where the suffix for alcohols, in fact I was supposed to edit here, they have a suffix. The suffix for alcohols is ol, right? So if you remember, the suffix for alkanes was ane, so every name would end with ane. The suffix for alkenes was ene, so every name would end with ene. You'll find ethene, propene, and so on and so forth, or propane, ethane, methane. In this case, you'd find ethanol, propanol, and so on and so forth, right? So that's what's happening. So now if there are two of these hydroxyl groups in the main chain, you then use diol as your suffix, okay? And then if there are three, it becomes a triol, okay? So those are the rules to naming alcohols. So now let's focus on the types of alcohols, but first we must remind ourselves about the types of carbon atoms. We said there's a primary carbon atom which happens to be attached to only one other carbon atom, and then we said there's a secondary carbon atom which is usually attached to two and only two other carbon atoms, nothing more, nothing less, right? And then we said there's a tertiary carbon atom, and that one is usually attached to exactly three carbon atoms and nothing more or nothing less. All right, so that's that. And then now we said in the case of haloalkanes, remember we said this gives rise to a primary haloalkane where the substituent or the halogen atoms is attached to the primary carbon atom. So now, since we are talking about alcohols, I wanted to show you that the rule is the same. The only thing that's changing is that now, instead of a halogen atom being attached to a primary, a secondary, or a tertiary carbon atom, it'll instead be a hydroxyl group because we are dealing with alcohols now, right? So we have three types of alcohols, okay? So it all depends on whether the hydroxyl group is attached to a primary, secondary, or a tertiary carbon atom. So let's start with primary alcohols. Right, we find that the hydroxyl group the hydroxyl group would be bonded to a primary carbon atom. So in that case, we will say, let's take the hydroxyl group and put it here, right? If you check our hydroxyl group now, is attached to a carbon atom that happens to be a primary carbon atom, right? So this would be a primary alcohol. The name of this alcohol would be ethanol, because there are 2 carbon atoms. So this would simply be ethanol. Right, so that's what happens with alcohols as well. You have a primary, secondary, and a tertiary alcohol. So let's go to a secondary alcohol. So instead of now the hydroxyl group being attached to a primary carbon atom, it's instead attached to a secondary carbon atom. Okay. Right, so the hydroxyl group is attached to a secondary carbon atom, and we already know what a secondary carbon atom looks like, so we can put our hydroxyl group here. Okay, it's either you put it like this or you put it like that. Still the same thing. All right, so that's our hydroxyl group. Okay, all right, so this one would be propanol. Okay, or propanol, but we will learn about those and how to name them later on. And then now another example or another type of tertiary alcohols, of alcohols, is the tertiary alcohols, where the hydroxyl group is bonded to a tertiary carbon atom. If you check here, we have our hydroxyl group bonded to this carbon atom, and that carbon atom is in turn bonded to 3 other carbon atoms. All right, so which makes this a tertiary alcohol. So this alcohol would be what you call (2.2) dimethyl and then we put, of course, don't worry about it for now, we will learn how to name alcohols again, I repeat, later on. So yeah, but this one would be a, oh, not 2.2, sorry, 1.1 dimethyl and then ethanol. Yeah. All right, so now that we have mentioned all the types of alcohols and also the rules on how to name these alcohols, we can pretty much start with our examples. Okay, so remember, rule number 1 said, first things first, we find the longest carbon chain, but that carbon chain must contain our hydroxyl group, otherwise it's invalid. So let's try and check this one. All right, so if we count from left going to right, we'll have 1, 2, 3, right? 3 carbon atoms. So this would be prop, right? Now let's check if we count So if you check my chain, it contains the hydroxyl group. All right, and then if I do 1, 2, 3, I still get to include my hydroxyl group. If I do 1, 2, 3, I still get to. So it doesn't matter which chain we use, the number is the same. They are all containing 3 carbon atoms. So I'll opt to use for the straight chain, because I always go for what's convenient, right? So let's say we use this one. Then this is our chain. So that's our chain. All right, so if you check here, we were told as part of the rules that we must start numbering from the side nearest to the hydroxyl group. So the hydroxyl group is closer if we start numbering from this side, going that side. So from right going to the left. So we can go and say 1, 2, 3, right? It wouldn't work if we started numbering from left to right instead. So if we started numbering from this side going that side, it would not work, because it would put our hydroxyl group on carbon atom number 3. So let's see that 1, 2, 3. So you see, right? So we have to number from right to left in this case. All right, so we mentioned that we number the chain from right to left, as this is nearest to the to the hydroxyl group. Right, compared to numbering from left to right. So now we can start filling. Remember, we always create this nice template of ours, so that every piece of information that we need, we can step by step extract it from the structural formula, and thereby end up having a final IUPAC name. So we'll start with the number of carbon atoms in the parent chain. We find that there were 3. The stem name, as a result, the stem name for this carbon chain would have to be prop. Why? Because there are 3 carbon atoms. And if you remember from our table of stem names, we had 1 to 10, 1 being meth, 2 being eth, 3 carbon atoms being prop, 4 carbon atoms being but, and all the way to 10, where 10 carbon atoms would have to be DEC, DEC, right? So now, what is the location of the hydroxyl group OH? It is on number 1, carbon atom number 1. If you check here, we said it's on number 1, because we're numbering from right to left. All right, so now the name of the substituent, it's only the hydroxyl group. If there was another substituent like methyl group, wait, let's just double check. Oh yes, we have 2 other substituents, because if you check, this is our main chain, and anything outside of it is called a substituent. This includes our hydroxyl group, and then we have our methyl group, and then now we have another methyl group, all right. So when it comes to these substituents, we have to include all of them. So we have methyl group, which is the CH3 that we saw there, and then we also have the hydroxyl group. So these are the 2 substituents that we can note that are present in our organic compound or in our parent chain, which is the OH. All right, so the type of alcohol that we have is Is it a primary, is it a secondary, or is it a tertiary alcohol? So if we check, the hydroxyl group is attached to this carbon atom. This carbon atom is only attached to one other carbon atom, no other carbon atoms, okay? So this would have to be a primary alcohol. And then we have to also note the positions or the locations of the methyl groups, because we already know the location of the hydroxyl. Now, what about the methyl groups though? The methyl groups are in position 2, or in the second carbon atom along the parent chain or along the main chain. All right, so we didn't add that column, that row here, but we have to keep that in mind. So now, what is the IUPAC name? Remember, with the IUPAC name, when we start naming, we have to prioritize the alphabetic arrangement of these things. So what comes first? Is it M or is it O? Let's do this. So M comes first, right? So therefore, we will first name the methyl groups, and then followed by the name of the parent chain, and then also the position of the hydroxyl group, because the hydroxyl group is our functional group. All right, so let us do it. We notice that there are 2 methyl groups. So once you have 2 identical alkyl groups, you have to use a Greek prefixes. So in this case, there are 2 of them, so we have to use di. So it will be dimethyl. So let's start there. We will have 2.2 or comma 2 dimethyl. All right, now we can mention the name of the parent chain, which is prop. But before we do that, we have to include the position or location of the hydroxyl group, of course, along the parent chain. So we said the hydroxyl group is on carbon atom number 1. If you check here, it's on carbon atom number 1. So therefore, it would be 1, and then it's prop. And then remember our suffix here, since it's alcohols, our suffix is OL. That's our suffix, so it's going to be propanol. All right, so we always add that anol there, but our suffix is OL, okay? So what that means is, let's just check our stem names, and let's just remind ourselves on how they work, right? So if you remember, we said if there's 1 carbon atom, that stem name will be meth, and then what happens after is dependent on the homologous series. So in this case, we're dealing with alcohol, so that's our homologous series. So the suffix that we would use is OL, and of course it depends how many hydroxyl group or groups are present in the parent chain or in the main chain. If we have 1, we just use OL. If we have 2, we have to use diol, di-OL. If we have 3, it has to be triol, tri and OL, right? So in this case, let's just assume there's 1. So the name of the parent chain would be, for alcohols, in the case of alcohols, if we were adding suffixes to these stem names, right, we would say methanol, right, ethanol, propanol, butanol, pentanol, hexanol. So you see, this is how we would name the parent chains of alcohols. But what normally happens is, once you pass ethanol So from here to here, you can easily say it's methanol, ethanol, and propanol. But after propanol, it's hard to say butanol because you have to mention the location of the hydroxyl group. So you'll end up having something like 1-butanol, for instance. Not just butanol on its own. It will be accompanied by a number that tells us the position or the location of the hydroxyl group. It's not just possible to say it's butanol, right? So it's not that simple after propanol. So you only are less likely to use numbers for methanol, ethanol, and propanol. But after butanol, after propanol, you start using numbers, right? So this would be heptanol, octanol, nonanol, and decanol. All right, so that's what happens, right? Of course, there'll be a number here. It could be 3-decanol, could be 5 nonanol, maybe 4 octanol, right? But the main idea here is to show you that we're still using the same stem names. It's just that now, since we are at a different homologous series, we have to change the suffix to OL, right? So that's what's happening. In fact, I was supposed to do it like this because the suffix is the right. Right, so I was just supposed to, we'll see now in a second. All right, so just to highlight that the OL is the suffix, all right, not the ANOL, but the OL. So this is what would happen. Okay, so these are all our parent chain names, and then of course, like I said, it would then depend, is that chain name, does it have, or that chain, does it have more than 3 carbon atoms? Because if it does, then we have to mention the location of the hydroxyl group. Or does it have other substituents except the hydroxyl group on the main chain? All right, so yes, let us continue with our numbering, or with our IUPAC naming of the other alcohol compounds. All right, so before we just continue, I forgot to mention that here you also have another alternative. So you can say 2.2 dimethyl propanol, 1-propanol, or you can say 2.2 dimethyl propan 1, and then you put your suffix at the end, right? So you can also do it like this. If you remember, we had something like this as well when we were dealing with alkenes and alkynes. You can decide to put the location of the hydroxyl group in this manner instead of putting it before the name. All right, so in this case it was before the name of the parent chain. In this case it's after the name of the parent chain but before the suffix of the homologous series. All right, so yes, that's one thing. Okay, now let us focus on our next example. So now we have this one, right? This is a condensed structural formula. So here we can identify our parent chain as well. If you can check to make sure that it includes both, because we have 2 hydroxyl groups now. So to make sure that this chain includes both hydroxyl groups, it's clear that this is the only chain that would allow that. So this has to be our main chain or our parent chain. All right, so let us count how many carbon atoms we have in our parent chain. we have 1, 2, and then 3. So this would be a propanol main chain or a propanol parent chain. So which side is it better to start numbering from? If you check, even if I start numbering from left to right or from right to left, it doesn't make a difference. Okay, let me show you why. If we number from right to left, we will have 1, 2, 3, right? The first substituent or the first hydroxyl group is in the first carbon atom, and the last one is in the last carbon atom. Now, what happens if I number from left to right? I'll have 1, 2, and then 3. The first substituent is in carbon atom number 1, and the last one is still in carbon atom number 3. So it doesn't make a difference. So you can number anyhow here. So in this context, or in this case, you can number from any side. Right, so we can number from either side, it doesn't matter. It yields the same result. So let us go to our table and start filling. All right, so now if we check, we have 1 hydroxyl there and the second hydroxyl here. So it means we would need to use the Greek suffix di, the Greek prefix di, this one. Okay, so this is a diol. Our suffix would therefore be a diol. I'll show you how that works in a second. All right. So how many carbon atoms are in the main chain? We found 3. The stem name of the main chain would be prop, because there are 3 of them. The location of the OH is 1, let's say 1 and 3. All right, and then it's only the hydroxyl groups that we're dealing with, so our substituents are just the hydroxyl groups. Right, and then the type of alcohol, this would be a primary alcohol, because if you check the OH groups, they are both attached to a primary carbon atom. All right, so this would qualify to be a primary alcohol. Okay, so but we have to note that our suffix would be a triol now, a diol, because we have 2 hydroxyl groups and we therefore cannot use the OL as it is, which is the general suffix for this homologous series, or the general suffix for alcohols. All right, so we have to note that. All right, yeah, we've added that piece of information. The suffix will now become diol because there are 2 hydroxyl groups that are present in the parent chain. Okay, so let us work on the IUPAC name now. So since there are no other substituents, so there's no methyl, ethyl, or any other alkyl group or any halogen substituents, so therefore we will just go straight to the locations of the hydroxyl groups, which happens to be 1.3. Then now we can include the stem name or the parent chain name, which in this case would be propanol. Okay, so normally it would be propanol like this, but now remember there are 2 of these hydroxyl groups. So it must change from propanol to propandiol. All right. Or remember, you can name it such that you have prop, which is your stem name, the position of your hydroxyl groups, which is 1 and 3, and then the suffix, which is diol. It's actually propan, sorry. Propan 1.3 diol. So this is how we would name a diol, or an alcohol that happens to have 2 hydroxyl groups in its main chain. All right, let's see, we did not miss anything. Okay, yes, we are good to go through our next example. All right, and then let's check this one. If you check here, we have 3 hydroxyl groups, 1, 2, and then lastly 3. Okay, so in this one as well, the main chain is clearly this one, or the parent chain. There's no need to look for it. It's this one, right? It's clear, it's in our faces, right? So now in this case as well, if you check, it doesn't matter which side you start numbering from, you'll get the same thing. What's in the middle will be in the middle, which is this OH group, What's on the sides, the first and the last carbon atom would be on the first and the last carbon atom, irrespective of which side you start numbering from. So just to illustrate this point, if you come here and start numbering from right to left, for instance, you'd have 1, 2, 3. So the first hydroxyl group is in the first carbon atom, the second hydroxyl group is in the second carbon atom, and the third hydroxyl group is in the third carbon atom. Now if we do it the other way around, where you start numbering from left to right, you get the same thing again. So it doesn't really matter which side you start numbering from here. So we can start with our process of how we name these alcohols. Okay, but first we must note that what happened here is almost same as what's happening here. Now the only difference is here, since we have 3 hydroxyl groups, the suffix will change from ol to triol, or in this case we had 2, so it was a diol. Now we have 3, so it will be a triol. So let me just take this. So here we're saying it changes to a triol. Okay, and then it also doesn't matter we number from. Now let's bring our table here. All right, first things first, we have 3 carbon atoms in the main chain again. We can take that and put it here. We have 3, therefore this would be a propanol or a prop. Let's leave it to prop. Right, that's our the name or the stem name of the main chain, right? In fact, it's just propanol, but I would leave it as the stem name, because the suffix is not always ol like in this case, so we will write that at the end. So the location of the hydroxyl group is 1, 2, and 3. Right? The type of alcohol, we can't really tell, because if you check the middle hydroxyl group, it's attached to this secondary carbon atom. Why is this a secondary carbon atom? Because this carbon atom is attached to that carbon atom and also that carbon atom. So it's attached to 2 other carbon atoms. So that's why it's a secondary carbon atom. But if we check the other 2 hydroxyl groups, they are actually attached to primary carbon atoms. So we can't really say, or we can say it's a bit of both. It's both a primary and a secondary alcohol, depending on which hydroxyl group you're looking at, or from which hydroxyl group's perspective. All right, so we'll leave that for now and then go to the IUPAC name. Right? Oh, we made a mistake here. This is supposed to be there. And then we said the name of the substituent is a hydroxyl group. There are 3 of them actually. And then now IUPAC name, since there are no other substituents here, it's mainly the hydroxyl groups. We can just start by listing their locations, and then from there we put our stem or parent chain name, propan. But since now it's not just going to be simply propanol, because there are 3 hydroxyl groups, so we have to add our Greek prefix tri. So it's going to be propan triol, right? Or we will say propan 1, 2, 3, and then we put our suffix at the end. All right, so that's another way of naming a triol or triol. I don't know how to pronounce this, but it doesn't matter as long as you know how to write it. So now this is how you would name an alcohol that has 3 hydroxyl groups. So if you check, we started with an alcohol that had 1 hydroxyl group, we did an alcohol that had 2, and then we did an alcohol that had 3 hydroxyl groups, and none of these had other substituents except the alkyl group or the hydroxyl group, right? So we will also look into how do you name it if it has now a halogen atom as part of the organic compound or as part of the structure. All right, but first let's check this one. Okay, so we have this. This is again a condensed structural formula, and let's check the longest continuous chain, and remember it must always contain the hydroxyl group. If you check, our hydroxyl group is here, so whatever chain that we identify as our main chain must contain this. If it doesn't, we can't call it a main chain. Okay, so let's start numbering. Let's start with the straight one. 1, 2, 3, 4, 5, 6, just 6. Okay, so this will include the hydroxyl group. Okay, what if we start here? 1, 2, 3, 4, 5. Okay, this one won't work, it's not the longest. What if we start here? 1, 2, 3, 4. This one also won't work. So clearly what we can use is the long one, which is the straight chain, this one. So that's our main chain. So now what we can do, can put that there to mark our main chain. Okay, now where do we start numbering from? Remember, from the side that will be nearest to the hydroxyl group. Of course, now if you check, we have other substituents, but we won't prioritize them because this is an alcohol, so we must prioritize the hydroxyl group. So we have other substituents. We have the alcohol here, the hydroxyl group there. We have this alkyl group here. We have another alkyl group there, and another alkyl group here. So in total, we have how many substituents? We have 1, 2, 3, 4 substituents. How many hydroxyl groups do we have? We only have 1. How many alkyl groups do we have? We have 1, 2, and 3. All right, so that's how you distinguish them. All right, so I think at this point we can start deciding which side is it best to number the main chain from. So let's check. If we number from right to left, we'll have 1, 3, 4, 5, and then 6. So if we use this way of numbering, our hydroxyl group will be on carbon atom number 1. However, if we now use the other way of numbering, which is 1, 2, 3, 4, 5, 6, right, the hydroxyl group will be on number 6, on carbon atom number 6, whereas the other substituents, like this one, it will be on carbon atom number 4 here, and then these two will share carbon atom number 5, or will be both located on carbon atom number 5. All right, so but of course we have to prioritize the hydroxyl group. So it's best in this case to start numbering from right going to the left. So basically we're numbering from right going to the left, like that. That's our numbering. All right, so let us first note that it's best to number from right to left instead of left to right. All right, so how many carbon atoms are in our parent chain? We found 6. The stem name, if it's 6, remember it's hex. All right, so this we can simply write hexanol here, right? So because now if you check, we don't have any other hydroxyl group, right? So we can imagine that as your stem name, because that's what you would write in the final IUPAC name anyways. So the location of our hydroxyl group, we said, is in carbon atom number 1. The location of other substituents, that is, as we saw 3 other substituents, which happens to be the 3 alkyl groups. So 2 of those are ethyl. So this is an ethyl group. It's ethyl because remember it has 2 carbon atoms. So this alkyl group will be an ethyl group. This will be a methyl group. Right, and then this one would be also an ethyl group. Okay, so and then this is our hydroxyl. Okay, it doesn't fit here, it's fine. Just know that it's a hydroxyl group. Okay, so now we have the location of other substituents. We said the methyl group is on number 2 as well. This is 2 for the methyl group. Whereas the ethyl groups are located in both 2. One is in 2, which is this one, and the other one is on carbon atom number 3, which is this one. So we can say 2, 3, 4, the ethyl. All right, and then the name of the substituents, we have methyl, we have ethyl, And we also have the hydroxyl group. So remember, like I said, in your exam or test, you don't have to create a table like this. This is for me to show you that these are the things that you can extract from a condensed structural formula or a structural formula in general. In your mind, this will happen probably in just a few seconds in your mind, okay? With enough practice, you won't have to create these tables and so on. This is just to create the habit of taking out all the information that you have or that you can see on your structural formula before you create the IUPAC name, okay? So that's that. And then the type of alcohol that we have here would be, it's a secondary alcohol. Why? Because if we check, in fact, some people struggle with reading the condensed structural formula, but in actual fact, it's the same as the structural formula. The only difference now is you don't see those all the bonds that are present there, but it's the same thing. So if we check here, just this part, there's that carbon atom there, then there's this carbon atom, and then you get your hydroxyl group being attached there, right? These are the last two carbon atoms in my chain, or the first two, because I'm numbering from right to left, right? So if you check, this carbon atom is only attached to that carbon atom and no other carbon atom. As a result, this would have to be a primary alcohol. Excuse me. And then now let's go to the IUPAC name. So we said we have the methyl group and two ethyl groups. So we start with ethyl. Why? Because alphabetic precedence, right? So E comes before M. So when we are creating the final IUPAC name, we must be always aware of such things. So keep that in mind. So the ethyl group is in 2 and 3. So since it's available in 2 locations, or it's visible in 2 locations, or it's found in 2 locations actually, so now we have to use our Greek prefix di ethyl, right? And then let's see something. Right, so diethyl, and then now we mention the methyl group as well, which is on position number 2, methyl. All right, and then there's no other group except the hydroxyl group. So the hydroxyl is on position number 1. So we can say 1, and then now we can write the name of our parent chain, which is hexanol. Yes, so this is 2.3 diethyl, 2 methyl, and 1 hexanol. Or, right, you can say 2.3 diethyl, 2 methyl, and then hexan 1 all. Alright, so that's what we have there. So this is how you would name this type of alcohol, okay? Alright, now let us check our next example. In this example, we have a halogen atom present there as one of the substituents. So if you check, there's a halogen atom there. It's one of the substituents. But first, let's identify our parent chain. So here the parent chain is quite straightforward to see. If you check, it's just going to be this one, right? Because let's just count though. 1 2 3 4 5 6 7, right? 7 carbon atoms. Or we can go 1 2 3 4 5 6 7, still the same thing. So if you notice, both chains will contain 7 carbon atoms in them. So I'll just go for the straight chain because it's convenient. And it's something I can easily see. Right, so then we are left with 3 substituents, which is this one, the hydroxyl group, that one, the halogen atom, which is chlorine, and then this one, the alkyl group, which is methyl. All right, so those are our 3 substituents. Now, which side do we start numbering from? Let's check. If I start from right going to left, I'll have 1 2 3 4 5 6 and then 7. Okay, so on this one the hydroxyl group is on carbon number 6. Okay, on the other hand, if I start from left to right, I'll have 1 2 3 4 5 6 and then 7. So if you check here, the hydroxyl group will be on carbon atom number 2. So that's the location. So we would therefore have to choose numbering from left to right. All right, so because if we check, the hydroxyl group is closer when we number from left to right, so that's why. So that's the first thing. All right, so number for the main chain from left to right, this side is nearest to the hydroxyl group compared to when we number from right to left. Okay, now that we have mentioned that, let's bring our table and start crafting our IUPAC name. All right, so how many carbon atoms are in the parent chain? We found that there are 7. And then the stem name of the parent chain is hept, because it's 7, hept. Right, so you can think of it as heptanol. Now the location of the hydroxyl group is on number 2, carbon atom number 2. The location of other substituents, we found that the chlorine atom will be on carbon number, let's just check, it will be here on carbon number 4. Hydroxyl is on carbon number 2, and the alkyl group is on carbon number 6. So 4 and 6. 4 is for chlorine, and then 6 is for ethyl. Was it ethyl or methyl? Methyl. All right, so the name of these substituents, we have chlorine, we have methyl, the methyl group, and then we have the hydroxyl group. All right, what is the type of the alcohol though? If you check, the hydroxyl group is attached to this carbon atom. This carbon atom is in turn attached to this carbon atom and that carbon atom. So this would have to be a secondary alcohol. All right, then what's the IUPAC name? Let us make the IUPAC name. So first things first, remember alphabetic precedence. C comes before M. So we'll start with the chlorine. Where is the chlorine located? On number 4. So we can say for chloro, right? Then where is the methyl located on 6? 6 methyl. Where is our hydroxyl group located? We said it's on carbon atom number 2. 2 hexanol. So it's easy to say hexanol because there's only one hydroxyl group. If there were 2 or 3, we would use hexandiol or hexantriol. So here, or we can say right, we can say 4 chloro, 6 methyl hexan 2 all. So there are 3 ways of naming this one, because you can, there are 4 actually, because you can make this, instead of chloro you can just write chlorine there as is, right? That's also acceptable. All right, so that's how we would name this organic compound or this alcohol. So this alcohol, it had chlorine in it. Okay, so the rules don't change. We still prioritize the hydroxyl group when we are numbering the parent chain, and we make sure that we number from the side that is nearest to the hydroxyl group. And then when we name our final, when we do the final IUPAC name, we make sure that these substituents, they follow each other alphabetically across the name. So in this case, C comes before M. So chlorine will go first, followed by the methyl group, and then lastly the position of the hydroxyl group across the chain and the name of the parent chain. Okay, so yes, that's how we would do this one. That's example 5. So let's check example 6. So in example 6, we are told to draw the structural formulae for the following alcohols. So this will be the first one, second alcohol, and then this will be the last one. All right, so if you check, you remember this tells us the location of our methyl group. Obviously this tells us the name of the alkyl group, which is methyl, right? And then this tells us the length of our parent chain. Okay, and then this tells us the location of our hydroxyl group. Then this tells us how many hydroxyl groups we have, which is only one. That's why it's only OL and not di-OL or tri-OL. Okay, so that's one thing you must always remember. So now let's go ahead and do it. So I always start with the parent chain, and I just draw a straight parent chain, and I make sure it has exactly how many carbon atoms are being, according to the name, how many carbon atoms it will have. Okay, so according to this name, since it's pent, it means it will have 5. So we'll have 1, 2, 3, 4, and then 5. Okay, now we are told that the methyl group is on carbon number 3, which also happens to be the same carbon atom where the hydroxyl group is located. So we can go to carbon atom number 3, which is this one. We put our hydroxyl group there. It's either you throw it like this or you throw it like that, doesn't matter. For now, let's just throw it like this. And then we have our methyl group here. Okay, then we can fill the remaining carbon atoms with the hydrogen atoms that are always surrounding them. That's H. So if we check, we have number 3 for our methyl group. That's our methyl group there. We have alcohol being at number 3 as well. and this is our alcohol, our hydroxyl group, sorry, not alcohol. It's on carbon atom number 3. So this is how you would sketch something like this. All right, so now, so now we can go to our next example. Okay, so here we have 3.3 or 3,3 dichloropentanone. All right, first things first, 3.3 tells us that there are 2 of these substituents in the same carbon atom, right, in the same location. Then di, of course, is a Greek prefix, meaning there are 2 of them and they are identical. Otherwise, we wouldn't use di. Okay, so, and then that's the length of our parent chain. So it will be, since it's pent, it has to be 5. All right, this location of our hydroxyl group okay, location of chlorine, so look, chlorine is located at 3 and carbon atom number 3. Right, so let's just sketch our draw our structural formula. So 1, 2, 3, 4, and then 5. And then now we are told that the hydroxyl group is on carbon atom number 1 according to the name. All right, so we can put it here. You can either put it here, OH, or you can put it there, OH, or you can put it there, OH. It does not matter as long as it's in carbon atom number 1. I choose to put it there, here. All right, and then can put our H there. Okay, we have that now. So this is sorted, it's here. Okay, and then now we go to the chlorines. We are told that they're in carbon atom number 3. So this 1, 2, they're here. So it will be chlorine there and another chlorine atom there. Okay, so that does it for chlorine. Dichloro. So we have chlorine there and chlorine there. And then there's no other substituent that we have remaining, so we can just start populating the other bonds with hydrogen atoms. H, 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 H. Aha. There. So this is how you would draw the structural formula for this one. All right, let's check the final example. Here we have 5 bromo, 5 methyl hexane, 1, 3, 4 triol. So this one tells us that there are 3 hydroxyl groups. And their locations, right? So these are the locations, and then this is the length of our parent chain, right? And then the rest is the same. Location of bromine, And then this one would be the location of the methyl. Alright, so now we have all that information. Let us draw our structural formula. Remember, start with the main chain. We are told that it's hexane. So that means it has 6 carbon atoms. So let's draw them. 1, 2, 3, 4, 5, and 6. Let's start by populating it with the hydroxyl groups. The first one is here. Carbon atom number 1, OH. The second one is on carbon atom number 3. In fact, let me make them on one side so it's easy to deal with them. And then the other one, or the last one, is on number 4. Alright, so we have all of that. So we have all our hydroxyl groups, 1, 2, 3, all of them, right? And now let's put the other substituents. Let me start with bromine. Bromine is on carbon atom number 5, and so is the methyl. So I'll put bromine first, right? Doesn't matter whether it's up or down. So I'm choosing to put it down here so that I'll have more space to put my methyl group up there. That's methyl. And then we're done with the substituents, and we can start populating our carbon atoms with their H atoms. All right, so that's it. There's our bromine there, and it's on number 5. We have our methyl there. It's also on number 5. All right, so this is how we would draw structural formula if we were asked to draw them. And then as a result, we have done pretty much all the examples that would help prepare you or prepare your fundamental knowledge of alcohols. And I'll catch you on our next video. Cheers.